It is simply as a question, and based on the answer yes or no, it further split the tree into subtrees. So what is the purpose of using this decision tree? Is going to predict the class of given data set. It is simple to understand as it follows the same process which humans follow while making any decision in real life. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Student, let us start our discussion with the unit, the chapter, learning or machine learning. So, under this concept, we are going to talk about decision tree in this session. So, let us see what is a decision tree. A decision tree in machine learning is a supervised learning algorithm. So, in our previous session, I have explained you about the different forms of learning: supervised, unsupervised, and reinforcement learning. So, here decision trees, it is an example for supervised learning and used for both classification and regression. We have seen in the previous slide or previous session about what is classification and what is regression. They are the two methods in supervised learning. So it models decisions as a tree-like structure. So this going to design a model or is going to develop a model which looks like or like a tree-like structure. In decision tree, there are two nodes which are the decision node and leaf node. So in the decision tree, there are two nodes. One is decision node, second one is leaf node. So what is a decision node? A decision nodes are used to make any decisions and have multiple branches, whereas leaf node are the output of those decisions and do not contain any further branches. So this is the structure of a tree-like structure or decision tree. It has a node and decision node where we are going to take decisions, or it is a node, it takes all the decisions, and leaf node is the result of the decision. So this is the structure of decision tree. The decision or the test are performed on the basis of features of the given data set, obviously. So any decision takes place through the system, it is based on the data set and is going to develop its own model. So that is the decision tree. So decision tree is nothing but it is a supervised learning algorithm, and it is called a decision tree because it is similar to tree. I mean, the algorithm looks like, or the functioning of this algorithm or this decision tree is just like a tree. If I say tree, it starts with the root node. So the tree starts with the root node, then it's going to expand further branches and construct like a tree structure. It is called as decision tree because it is similar to tree where you can find the root and branches. It is simply as a question, and based on the answer yes or no, it further split the tree into subtrees. So it is possible now. A decision tree is a tree, and it is possible to have a number of branches based on the decision and depends on the problem. Similarly, it is also possible to have this a subtree inside a tree. So that is the meaning of splitting a tree into subtree. Look at this schematic diagram here. So in the diagram, decision node, or we say is the root node. And here, as we said, there are two nodes, one decision node, and here we have leaf node. If you observe this, here we have a decision node and leaf node. What you have seen in the previous slide, the decision node is the way, this is the node where it takes the decision based on the features of the data set, and leaf node is the result of this decision. So this is what you have seen the definition in the previous slide, and this is another node here, decision node, leaf node. And you can also have, if you look at this example, there are two leaf nodes, but here one is leaf node and we have one more decision node. Under this we have two leaf nodes. So it looks like a tree. This is the root, this is the root, and these are called the branches of a tree. This is decision tree. It is an example for supervised learning algorithm. Now, it usually mimics human thinking ability while making decisions. So, it is easy to understand this concept. So, what is the meaning of this? It is going to mimic, means simulate human thinking ability. As we know how we are going to take decisions. And if you know that, as we have seen in the previous slide, see any decision, it result in there are two possible answers, either yes or no. So based on that, it take a decision is going to simulate the human thinking ability while making decisions. So it's easy to understand the concept. Now the logic behind the decision trees can be easily understood because it shows a tree-like structure. So it is another advantage is that by looking at the diagram or schematic diagram, we can make out that, see, this is the root, these are the node, decision node or a leaf node and another leaf node, or we can have one more subtree. So this is itself is called as subtree. So it is easy to understand the logic behind the algorithm. In the next slide, we will see some terminologies what normally we use in decision tree. So one is root node. So what is root node? It is from where the decision tree starts. So it represents the entire data set and which further gets divided into two or more homogeneous sets. So what is the definition of root node? So if you look at the diagram here, this is a root node. This is nothing but a data set. So root node, it represents the entire data set and based on the data set is going to take decision. Again, is going to divide it into number of branches or number of nodes. So this is the definition of root node. Then what is leaf node? So what is leaf node? So if you look at the leaf node, these are the final output node and tree cannot be segregated further after getting a leaf node. So if you look at the schematic diagram here, so by looking at this is the root node and here we can see leaf node. So it is the last point of the node of the algorithm and it cannot be further divided into branches or it cannot be segregated into number of branches or leaf node. So this is the definition of leaf node and this is the result of the decision taken at the decision node. Next one is what is splitting. So it is the process of dividing the decision node or root node into subnodes according to the given conditions. Now the tree is going to grow or is going to expand into number of branches based on certain conditions. For example, if you look at this diagram here, see this is the decision taken here and it has taken any decision will be having the possible answers either yes or no. So if it is yes, it takes one route and if it is no, it goes to or is going to follow another direction or another branch here. So that is the meaning of splitting. So the splitting of a tree takes place. It depends on the decision taken at the decision node. So this is the meaning of splitting. Next definition is what is branch or subtree? A tree is formed by splitting the tree. That is called subtree. In the previous example, see this is a decision node, the root node, and here node, again decision node, and again here is the leaf node. So this entire thing, it forms a subtree. So this is the definition of subtree. It is formed inside after taking decision from the decision node. So here again this is a root node, this is again root node for these two leaf node. So this is a subtree. Now next definition is what is pruning. So it is a process of removing the unwanted branches from the tree. So if at all, if you feel that these branches or the leaf node are not necessarily, so if it's, then in that case it is possible to take out those unwanted branches from the tree structure. That is the meaning of pruning. Next definition is parent or child node. So what is the definition of this? The root node of the tree is called the parent node and other nodes are called the child node. So there are two concepts here. One is parent node, second one is child node. So as per the definition, the parent node is the root node is called the parent node and the another leaf node, another nodes from that particular node, that's the root node, is called the child node. If you look at the example here, in this example, so this is the root for us, from where this is the place where the decision starts or algorithm start functioning, working at this point. So this is a root node, and again it has two nodes here. Again, these are the two nodes, and these two nodes are called the child nodes, and this is the parent for this. And similarly, if you consider this subtree, in this example, this is the root node for these two leaf node. So this is the concept of parent node and leaf node. Now let us see how the decision tree algorithm function or works. First one is, in a decision tree, for predicting the class of the given data set, the algorithm starts from the root node of the tree. So what is the purpose of using this decision tree? Is going to predict the class of given data set. So we have learned in the supervised learning, one is classification as well as regression. So what is the meaning of classification? So what the meaning here is going to predict the particular object is belongs to which class or which category, which group. That is the purpose of this decision tree. It starts from the root node. Now this algorithm compares the values of the root attribute within the record. That's the real data set attribute, and based on the comparison, follows the branch and jumps to the next node. So here, whatever the values at the root node, whatever the values at the root node or at the node will be compared with the original data set in the node. So that is when based on that is going to take decisions or is going to some other root or some other branches. So that is how the tree is going to expand based on the decisions. So in this example here, this is the node. See, this is the place where we take the decision, isn't it? So in that root node, the value in the root node, for example, any value, any data in the root node is compared with original data set of the algorithm. So in that way, it's going to compare those two values. Based on this, it takes decision, or it jumps to some other route or some other path. That is the meaning of the sentence here. This is the meaning of that. Next, for the next node, the algorithm again compares the attribute value with the other subnodes and moves further. I mean, in the previous example, now this first it takes the value compared with the data set, then it takes decision like this. Either it come to this path or it follow this path. Suppose if it follows this path here, again the value of this will be compared with the data set value. Again is going to take decisions. Again it starts branching or expands the tree data structure. That is how it functions. Next point is, it continues the process until it reaches the leaf node of the tree. Means is the same algorithm continues till we get the result for that particular problem, or till we get a solution. It keeps on checking for the values with the value attributes along with the values in the data set and expanding the tree into number of branches until we get the result or till we reach the goal. See, this is how it functions. In the next slide, we will see some example. Suppose there is one example is a candidate who has job offer and want to decide whether he should accept the offer or not. See, this is one small simple example. So here, this is you can assume that this is a starting node, this is a root node, and these are all different branches of a decision tree. tree. Assume that this is a start node. So this is the place or the node where we have to start algorithm. So from here, what is the first condition here? Salary is between 50,000 to 80,000. So what is the one condition for this candidate? Has to decide. So based on this condition. So here salary is between $50,000 and $80,000. So suppose again there are two possible answers for him. Either he can say yes or he can say no. So suppose if we say yes, and suppose if we say no in this example, then if a condition is not satisfied, means the candidate is not happy with this, he has to decline the offer. Means he doesn't want to get into this particular position or a job. And suppose if he is willing to continue with the same condition, so then it is yes. Again, this is one more condition. So this is what you have seen in the diagram. This is the decision node. Decision node, it can be, it goes like this till we reach the solution. So again, the decision here, again, office near to home. This is a one condition. Now second condition. What is second condition? He is ready to work with this salary, and again he would like to confirm whether office near to home or not. Again, if it is no, means again he can decline this, he can reject this offer. Or suppose if he is willing to continue, yes. So if we say yes, he is willing to continue, then it comes to next condition. What is the next condition? Here salaries is okay. This also condition is true. Next condition is it provides cab facility. I mean, this particular candidate looking for some more solution. So you're asking for facility, cab facility. Again, if it's no, means he can decline that. And if it's yes, means the company is going to provide this cab facility, then he can accept the offer. So this is end of the solution, end of the problem. So at this stage we got the solution. So if you observe this, it looks like a tree. Start from the root node, and again it takes another decision, yes or no. If it is yes, it is going to take one path, and if it is no, it is going to take another path. So this is how the tree or decision tree, it is a supervised learning algorithm, functions. Now let us see what are the advantages of this. It is simple to understand, as it follows the same process which humans follow while making any decision in real life. So what example, what you have seen in the previous slide, it is a real-time example for decision algorithm. Next one is it is useful for solving decision-related problems. Second advantage, and it helps to think about all the possible outcomes for a problem. So all the possible outcome of a problem. So there is less requirement of data cleaning compared to other algorithm. So it is going to work with all possible values, and there won't be or very less percentage of cleaning and compare the values as it is work with different possible values. And here data cleaning and comparison is are very less. This is another advantage. Let's look at what's the drawback of this, disadvantages of this. It contains lot of layers which makes it complex. What's the meaning of layer? Lot of layers. It may take more number of steps to come to a conclusion or to reach the final goal. That is the meaning of it takes a lot of layer for and makes it very complex. Next one is it may have an overlifting issues which can be resolved using random forest algorithm. Again, in the case of complex problems, we may have to use another algorithm, that is a random forest algorithm. For more class labels, the computational complexity of the decision tree may increase. In general, we can say that this may not be an optimal algorithm or right algorithm for complex problems. That is the main disadvantage of this decision tree algorithm. Students, so far we have discussed about a decision tree. It is one of the supervised learning algorithm. Let us continue our discussion in my next session. Thank you very much.